Areas related to circles. In this module, you will understand about area of circle and area of sector and segment of a circle. Let us understand why it is important to find the areas and perimeters of a circle in our real life. There are so many things around us which are in a circular shape. The most common circle shape we all use is a wheel of a cycle, a bicycle, a car, and a truck. The area or the size of the wheels is different of different vehicles. So it is important to find the area or the perimeter of a wheel to design a wheel of a vehicle. Some other example of circular shapes that we use in daily life are bangles, clocks, pizza, cake, etc. Thus, to find the areas and perimeter of the circles are very important, as the size of the circles vary. In earlier classes, we have already learned to find out the areas and perimeters of different figures, such as a rectangle, squares, triangle, etc. Let's see how to find perimeter and area of circle in next slide. Do you remember the circumference? Yes, the circumference is the distance around the circle. Perimeter of a circle is often called as circumference. Perimeter or circumference is proportional to a diameter and a radius of a circle. If you remember that the circumference of a circle has a constant ratio with its diameter, and it is denoted as pi. We can find the circumference using a formula, that is, circumference equals to pi into diameter. Now, diameter equals to 2r, where r is the radius of the circle. So we get a formula for finding the circumference or perimeter equals to 2 pi r. If you remember, there is an appropriate value for pi, and that is 3.14, and the other is 22/7. Our great Indian mathematician Aryabhat in the century 476 to 550 had discovered and given us the appropriate value of pi, that is 3.14. But in the period between 1887 to 1920, the mathematician Srinivas Ramanujan gave other appropriate value of pi, that is 22/7. Thus, generally we use 3.14 or 22/7 as pi. Now, to find the area of a circle, we use the formula pi r square, which can be verified as by cutting a circle in equal parts, as shown in the figure. Then, divide one of the sector into two equal parts, as shown in the figure. You can see there were 12 sectors. Then one of the sector has been divided into 2. Now total, we have 13 sectors of a circle. Then the sectors are arranged in a rectangular form. Now from this we can find the height and width of this rectangle. Here height is the radius of a circle as shown in the figure. And width is half of a curved part along with the circle's edge, which is called the half the circumference. As understood before, the circumference is equal to 2 into pi into r. So the half circumference will be pi into r. Thus, by putting the width and height into rectangular shape, which we formed from a circle, we can calculate the area. As such, area of a circle is equal to height into width equals to pi into r equal to pi r square. Thus, area of circle can be calculated using formula pi r square. Let us now learn about the area of a sector of a circle. In simple terms, a sector is a part of a circle enclosed by two radii of a circle and their corresponding arc. Example, a pizza is a circle and its slice is a sector. There are two types of sector, that is the minor sector and the major sector. The larger portion of a circle which has been cut by the two radii is known as major sector, and the smaller portion in a circle is known as minor sector. In this figure that the region OAPB is the minor sector and region OAQB is the major sector with radius r. The measure of angle of the major sector is 360 degree minus angle AOB. Let degree of angle AOB be theta. Now we know that area of the circle is pi r square. So if we consider a whole circle to be a sector, then it will become an angle of 360 degree at the center O. Now, if the degree measure of the angle at the center is 360 degree, then the area of the sector would be pi r square. Now, if we consider the measured degree of the angle at the center is 1, then the area of the sector would be pi r square divided by 360 degree. Therefore, if the degree measure angle at the center is theta, then the area of the sector would be pi r square divided by 360 degree into theta. Thus, we conclude a formula for finding the area of the sector of an angle. Theta equals to theta divided by 360 into pi r square. We also can find the length of the arc by considering the whole length of the circle as 2 pi r and the measure at the center as 360 degree. So we obtain a formula for the length of an arc of a sector of an angle. Theta equals to theta divided by 360 degree into 2 pi r. Now we will learn area of the segment of a circle. Segment of a circle is the area of the circle bounded by a part of its circumference and a chord. In this figure, the shaded portion of a circle bounded by the arc APB and the chord AB is known as segment of a circle. There are two types of segments, that are major segment and minor segment. In the figure, you can see that the shaded portion APB is the minor segment and the other segment AQB is the major segment, made by the same chord AB. Now let's find the area of the segment of a circle. In the figure, you can see we have taken center O and the radius r, thus considering the area of the segment as APB, which will equals to area of the sector OAPB minus area of a triangle OAB. So we get the formula as theta divided by 360 into pi r square minus area of triangle OAB. Also, we observe that area of major sector OAQB is equal to pi r square minus area of the minor sector OAPB. And area of major segment AQB equals to pi r square minus area of the minor segment APB. Let us solve some examples. 1. Find the area of the sector of a circle with radius 6 cm if the angle of the sector is 60 degree. Here we need to use the formula of area of the sector, that is theta divided by 360 degree into pi r square. Now theta is given as 60 degree and the radius given as 6 centimeter. So placing data as per the formula, we get 60 divided by 360 into 22 by 7 into 6 square. After calculating, we get area of sector equals to 18.84 square centimeter. 2. A brooch is made with silver wire in the form of a circle with diameter 35 millimeter. The wire is also used in making 5 diameters, which divide the circle into 10 equal parts. Find 1. The total length of the silver wire required. 2. The area of each sector of the brooch. First, we will solve the total length of wire required. Now, in this, we need to find the circumference, which is equal to 2 pi r. We know 2r is equal to diameter, and the diameter given here is 35 millimeter. So, we will substitute 35 millimeter in place of 2r, which will equals to 35 pi, and the values of pi taken as 22 by 7, which is equal to 110 millimeter. Now for making 5 diameter, it will be 35 into 5, which will be 175 millimeter. So the total length of wire required would be 110 plus 175 equals to 285 millimeters. Now we will find the second answer, that is the area of each sector of the brooch. As it is given that the circle is divided into 10 equal sectors, so the area of each sector will be 1 by 10, the area of the circle. Thus, by substituting the value of pi and r, we get the answer as area of each sector equals to 96.25 square millimeter. Let us revise all that we learned in this module, areas related to the circles.